Okay, and welcome to episode 1 of Armchair. Today we're doing contemporary issues in science, and today's issue is the measurement accuracy of the known universe. And Dr. Simon David, can you enlighten us on that issue, please?
So what we're going to be talking about today is the known accuracy of the modern universe, which now scientists believe is 1%, which is basically the 1% that we don't know about. Now, the 99% that we do know about, Earth, the sun, humans, dinosaurs, anything that you can think of.
Fossil fuels.
Human history, that's the 99% that we know about.
Like George Bush and like
George Bush, Barack Obama, the United States. A lot of these are pretty big ideas that's what consumes most of the human population.
Like, I think when we're talking about this, we're talking about the physical things that we
know about, we can observe.
That we see, that are tangible.
That's right.
Tactile experiences that we're having with, like, these are things.
That's right.
This is the known universe we're talking about, right?
The known universe.
Okay.
Now the reason we don't know about that mysterious, 1%.
It's mysterious.
Is because Hubble can't see past Pluto. Pluto is the last planet.
All right, Dr. David, would you be able to explain the Hubble problem? How Hubble can't see beyond Pluto? What's the deal?
Okay. Yep. Now, one of the greatest achievements in human history, the Hubble telescope, built by Milton Humason in
for sure
late 17th century, 18th
top
century.
10. It's in the top 10.
Top 10.
Top 10 greatest achievements.
Right. Stairway to Heaven, Metallica Black Album.
Black Album, yeah.
Super Nintendo.
Super Nintendo, I would say regular Nintendo, but that's subjective, so
right.
Up for debate.
The issue is the clarity. Now, Hubble has a 75% accuracy in its visual field. It's conical, like time and space conical. Conical kind of wraps around itself. That's why you have time loops.
Right. And what he's talking about, it's spherical here.
It's spherical.
Keep in mind it's spherical, otherwise you won't understand. So
right. So it's like, think of yourself as driving, through the universe.
I think we can all see. We can all relate. We can all relate to this. We're driving.
Now, you have a blind spot. You got this big part of your car right here that you can't see past. Now, that's the part
It's kind of obnoxious.
It's obnoxious. It's silly because Hubble's the best achievement, like we said. Now, it's got 75% of the range is there, but it's got 25% here.
Yes.
25% here.
Peripherals, blind spots. Peripherals. Yep, very hard to see. So this is what Hubble is experiencing. It's like you're driving and you got your blind spots, and Hubble is essentially just
you can't see that
beyond
1% of the universe.
That 1%,
the entire 1% is massive. I mean, it's probably the size of Canada or
it's got to be the size of Canada,
Alaska.
And so the 1% is the peripherals of Hubble.
That's right. The peripherals of Hubble. It's that dead space. We call it dead space.
Dead space.
Or black matter.
Dark matter. The Black Death, I think, was named after it.
Yeah. Well, that's that was something different. That was in the medieval era. That was
maybe we'll get to that
500-600 years ago.
That's another episode.
That's a different topic, but we want to tackle this problem. We want to see that 1%. We want to know about the entire universe. The problem is, what are we going to do? Relocate Hubble? How much money is that going to cost?
Well, you know what I say. Taxation will pay for everything.
Taxation.
We tax the poor and get way more money.
Tax the poor and move corporations move in that direction.
Yes, and it allows the corporations to move Hubble to where they need it to be, so we can understand that 1% beyond Pluto.
Right, and now if you want to think of the moon's orbit around the Earth, right? Okay. That's a full sphere.
Maybe
now the Earth is facing one direction. See, here in the U.S., you see one part of the sky.
Yeah, you only see that part of the sky.
That other whole part behind us, the moon sees it because it orbits us.
Yes, it's orbiting, obviously.
You put Hubble on the moon. Full 360, full.
Okay.
That 1%, that dead zone, is now 100% rather than 99%.
So relocating Hubble.
Now here's a couple of issues that come to mind. Where's the money going to come from?
Well, that's what I was saying. We tax the poor and let the corporations take control of it. Then we got easy solution. Easy. I don't see any.
Cut education, cut welfare.
I see no problems with that.
Cut Obamacare. That's trash.
Yeah.
How are we gonna power something like this? The amount of energy that it's gonna take on an annual level. So we're thinking clean wind energy.
Clean wind energy. Now, see,
the thing with wind energy, that orbit, that
Oh, there's so much wind on the moon.
So much wind on the moon. It's an unbelievable amount.
And remember, it's spherical, so it's insane, that amount
Right,
of
it's
wind.
like a turbine in itself. It's like when you saw the, Neil deGrasse Tyson landing on the moon and
Yeah, when you landed on the moon.
Alex Baldwin.
And welcome back to Armchair. We just finished talking about moving Hubble to the moon, and Dr. Simon David here has explained the problem to us, and we came up with an easy solution on how to do that. But my question now, to the folks at home here, and mainly to my cohort here, Dr. Simon David, is if we came up with such an easy solution to getting Hubble up there,
Right.
why aren't we landing regularly on the moon? Why haven't we colonized the moon yet? We talk about that. We want to do that. I think we all want to do that. We all want to live on the moon. Why haven't we done that yet? So, yeah, if you could please just enlighten us on that, Dr. Simon David.
Great question. You're wondering how and why are we going to colonize other planets and when? It's reasonable. Anyway, here's a diagram. Here you have the sun. Okay, hydrogen, helium, oxygen, all coming at us explosively from there. Now the Earth, right here, and the moon. You got obviously a couple planets in between. Now, when the sun orbits the Earth, you have a 360 rotation of it. Here's the moon's view of the observable universe. Now the moon orbits the Earth, just as the sun does. We can see like this, okay? About 75%. We can see that. What about this other 30%? Can't see it. Now if we put Hubble onto the moon right here, full 360 rotation, there you have it. 100% of the observable universe known to us, right here in the US of A.
And there you have it. I think we answered that question very clearly. I'm Dr. Chance Brandon.
And I'm Simon David.
Come have a seat in the armchair with us next time. Is it done running?
That's fine because then you can have music on after.
Is it done?
Yeah. I don't know.
Is it still running or is it done?
I don't know. It's your show. How would I know?